Swayam Prabha. Digital India. Educated India.
Of waste, waste management, the availability of waste, and the last we have seen that the waste to energy conversion, this concept is being developed, and in 2013 in Poland the incineration was used for the conversion of waste to energy. In this part we will discuss the need of energy production from waste, energy from waste. I will give you some scenario, world and Indian scenario, and at last we will discuss on the routes of energy production from wastes. Actually, as discussed in the first part of this module, waste to energy conversion gives us double benefit. One way it meets some energy demand, on the other way it gives us a systematic solid waste management system. In short, we can say this concept helps us to achieve the sustainability goal of the society, which is the need of the society of 21st century. Second, increasing generation of wastes and power demand, that is also important fact which is guiding us to develop some technology for the conversion of waste to energy. I will give you some statistics on it, how the waste generation is increasing day by day and how the power demand is also increasing. Then the energy potential of some solid waste components and wastewater. With the development, particularly the economic development, the composition of solid waste is changing and it is favoring for the waste to energy conversions. I will give you some statistics and informations on it. And reduction of inert in MSW, it is also similar to that with the development of the economy, the inert component in the solid waste is reducing, which is not desirable for solid waste conversion for energy. So, all those factors are guiding us for the development of a new technology for the conversion of waste to energy. Now, the first one is need of sustainable development. We heard the word sustainable or sustainability everywhere nowadays, but what sustainability actually means? Sustainability or sustainable system, say we can say system sustainable if the resources available in the system today is available in tomorrow and will be available for a longer time for our next generation also. So, this is the one way of explaining the sustainability, but the most logical way of explaining sustainability is that the system must be economically viable, environmentally bearable and socially equitable, actually 3 E. So, these 3 E, economics, environment and equity. So, these 3 are very important to achieve a sustainability goal. So, waste to energy conversion helps us to manage the waste in a proper way, so that health impacts are reduced. So, it helps to get better environment. Second is it is adding some value or some energy supply. So, economics may improve or the process may be economic, and socially it will create job of different natures. So, all gender people will be involved in this. So, social equity will also be maintained. So, waste to energy conversion has a good potential to help to get the goal of sustainability to the society. If we can develop some systematic way of solid waste management, so we can avoid some health hazards. As mentioned in this slide, you see that if we do not manage it in properly, the solid waste can cause air pollution, water pollution and soil pollution, or MSW clogged drainage system, and it creates stagnant water for insect breeding, floods during rainy season, etc., and greenhouse gases can be produced for open dumping and we will get global warming. So, health problems such as nose and throat infection, breathing infections and bacterial infections can be spread if we do not have any proper solid waste management. Now, the increasing generation of waste, we see here some statistics. In 1999, per capita urban MSW generation was 0.52 to 1.1 and it is kg per day, and it is expected to be 0.8 to 1.5 kg per day in 2025 for middle income countries. For low income countries, this value is going to be changed from 0.45 to 0.9 to 0.6 to 1.0, and further for high income countries it is going to change from 1.1 to 5.07 to 1.1 to 4.5. So, from this data it is very clear that in future the waste generation is going to be increased. The country like India, we are in between low and middle income countries, our waste generation productions is expected to be increased in future. Now, we will see some potential of the MSW generated in Indian cities for electricity production. Some examples are given here like Greater Kolkata, Greater Mumbai, Delhi, Chennai, Greater Hyderabad, Greater Bengaluru and Pune. So, MSW generated per day is given here. This column gives the calorific value of these solid waste and power production potentials is given here. So, some other Indian cities are also given in this slide, that is Ahmedabad, Kanpur, Surat, Kochi and Jaipur. Apart from these, we have data for more 59 cities of India, and on average we have 81,407 ton per day MSW generation capacity in these cities, and which has the capacity to produce 1292 megawatt of electricity. Then I will show you some data on how the inert in the MSW is reduced day by day. If we consider 1973, 1995 and 2005 cases for compostables, 1973 it was around 40% and 2005 it is increased to more than 50%. So, around 10% increase within 1973 to 2005, and for recyclables it was around 10% in 1973, it is increased to around 18 or 19% in 2005, and for inerts surprisingly in reverse trend we see here, that is inerts in 1973 was around 48% and it is reduced below 30% in 2005, and all those changes are favorable for the energy conversion from the wastes. Now, I will show you some data which justify the requirement of the energy production, the gap of demand and supply. This slide gives the name of different states of India, and it gives the million of people which are not getting any access to the electricity, and in rural area as well as in urban area, and it is also giving the percentage of people not having access to electricity in rural and urban areas, and on average basis, on total basis, we are getting 237 million people are not having access to electricity in the country, which is around 19% of the population. So, we are lacking the energy, we need more energy, but resource, and we have the waste generation capacity. So, if waste generated in different parts can be converted to energy, so some sort of energy supply can be made from this. Next we will discuss on energy from waste, and we will provide you some scenario. So, this slide is taken from Waste to Energy Technologies Market Global Industry Analysis Key Trends and Opportunities 2016 to 2023. As per this report, waste to energy or W2E technologies use municipal solid waste or any waste material containing huge amount of renewable and organic contents to generate heat, electricity and fuel through several complex conversion methods. The considerable amount of municipal solid waste around the world has given the waste to energy technologies a new lease of life and the much needed impetus. Several environmentalists and other players such as Foster Wheelers, ABB and China Everbright are working towards for commercializing the technology for energy conversions from the waste. Here we will give you some world scenario first. So, this is some information on waste to energy conversion in Europe. In EU 27, over 400 waste to energy plants are available which are based on incineration, and approximately 22% of the total municipal waste is processed through this process, and the technology is supplied by CNIM, which is around 30 to 35% of their products are here in this region. And we see here interesting information here, that is 88 million tons of remaining waste in Europe has been processed through incineration in the year 2014, and through this waste to energy conversion both heat and electricity generated. So, 88 billion kilowatt hour heat is generated and 38 billion kilowatt hour electricity generated, which are supplied to 15 million inhabitants and 17 million inhabitants respectively. By this process, it was possible to save 9 to 48 million tons of fossil fuels. Another information on waste to energy conversions in UK is available in this reference, that is ECO program multi-client study series waste to energy 2015-2016. As per this report, it is evident that in UK, Billingham 1 and 2, two plants, waste to energy plants are in active phase, and the capacity is 3,60,960 ton per day, ton per annum, and 2,91,840 ton per annum. Although the power production capacity are 29.2 megawatt and 21.0 megawatt respectively. Some other plants are also in planned and discussed phase. So, which will be using different capacity of solid waste and will produce different capacity of electricity, and in case of Belfast RDF both electricity and heat is generated. We will be discussing in later phases, in later modules, that the cogeneration or electricity and heat generation simultaneously improves the heat efficiency. Another example is given here, the waste to energy conversion activities in China. So, here Fengyang, Foshan and Fuing, these three are active plants having the capacity 5,76,000 ton per annum, 4,79,232 ton per annum and 3 lakhs ton per annum respectively, and their power production is 12, 30 and 14.8 megawatt. And another plant is also there under construction stage, and here also that Foshan 1 is using both power and heat. As you have discussed, this helps to improve the efficiency of the process. Now, we will see some scenario, Indian scenario. In India in 2014, as per 31st March 2014, on the basis of energy statistics 2015, it is clear to us that we had energy production capacity of 2,45,259 megawatt, total 2,45,259 megawatt total installed capacity as per 31st March 2014. Out of it, our renewable is 31,692 megawatt. So, what is this? The total is around 13%. So, 13% is renewable energy in the country as per 2014. But what is the potential we have? In the country we have potential of 1,47,615 megawatt. This is renewable energy potential we have. We are producing only 31,692 in 2014. That means we are using around 21% of this capacity. So, there is a good scope for further development on this renewable energy area. Here some statistics are there. Out of different renewable energy like say wind, solar, biomass and waste. We see wind is 70% potential we have, then hydropower, small hydropower, it has also potential of say 13%, biomass has 12% and waste has 2%, and cogeneration, that is heat and energy electricity generation using bagasse has 3%. So, this 12 plus 3 plus 2, so around 17% we have the potential out of these 1,47,615, the 17% is from the waste to energy and biomass to energy. Here as per the same energy statistic 2015, we see in 2014 the biomass and waste was used to produce 4,120 megawatt of electricity. So, this is the total renewable, this is the total renewable and this is the renewable energy from biomass and waste. So, what was the percentage? Around 13%, again it is also 13%. So, from this information we get that we have very less facilities for waste to energy conversion as per 2014 data, but gradually the efforts are on to increase this activity and in near future we may expect more waste to energy conversion in the country. Now, when some new concept is going to be implemented in a country, so we need some policy and those policies has to be framed by the government. In our country related to energy, when new policies formed, different organizations, different ministries are involved. So, this slide gives us some idea which ministries are responsible to fix some policy on energy. So, here central government takes suggestion from state government, it takes suggestion from Ministry of External Affairs, Ministry of Government Environment, Forest and Climate Change, Ministry of Railways, Ministry of Shipping, Ministry of Road Transport and Highways and National Institute for Transforming India, that is Niti Aayog. So, Niti Aayog itself contains Ministry of Power which has 6 PSUs, Central Electricity Authority, Bureau of Energy Efficiency and Ministry of Coal which has 3 PSUs and Ministry of New and Renewable Energy which has Indian Renewable Energy Development Agency, Solar Energy Corporation, several research institutes and Ministry of Petroleum and Natural Gas which has 15 PSUs, Directorate General of Hydrocarbon, Petroleum Planning and Analysis Cell, Petroleum Conservation Research Association and Department of Atomic Energy which has 5 PSUs, several research institutes. Now, we will see routes for energy production from waste. So, we have waste and biomass. We can convert it to energy through different routes. One is thermal route, that is incineration, gasification and pyrolysis. So, this will give us flue gas hot flue gas, that will give us electricity, steam or heat. Now, we will discuss in the next in some module how to improve the efficiency of these electricity productions using different types of turbines, etc., etc., and cogeneration options. Now, gasifications, it gives us syngas that gives electricity, chemicals, hydrogens, etc. Pyrolysis gives us bio oil, char and gas. This is the major thermal routes. Then we have biological conversion route. Biological conversion routes basically includes anaerobic digestion and fermentation. Anaerobic digestion gives us methane rich gas and fermentation gives us alcohol, acids, etc. This fermentation can be with the help of microorganism or will be with the help of enzymes. Next we have chemical methods, chemical routes. Chemical routes mainly includes hydrolysis, transesterifications and extraction, solvent extraction. So, hydrolysis is required to degrade the higher molecular weight organic compounds to lower acids. So, this is hydrolysis to break down the bigger molecules. So, it gives us cellulose, hemicellulose separation. Transesterification gives us the production of biodiesel from different sources like say waste cooking oil, or algal bio oil. Solvent extraction helps to extract bio oil from oil seeds, We have some other options, that is physical routes. So, physical routes include briquetting. This is a physical briquetting which gives densified solids with uniform properties and high strength, mechanical strength. This can be having your distillation which is used for product separation or mechanical extraction. Used for bio oil production. So, these are different routes which can be used for the production of energy from the solid wastes. There are some routes for liquid waste also. Before that, we will see out of these conversion routes the biological and your thermal. So, biological and thermal, these two routes are widely used for direct conversion of waste to energy, and this slide gives us some comparison. So, thermal route is effectively applied to almost any biomass feedstocks, but biological route will be applicable for selected feedstocks, and thermochemical route relatively higher rate of productivity, when biological routes the productivity is very slow and very less. Multiple high value products can be separated through the thermochemical routes, but biochemical routes are very product specific, and no effect of ambient temperature on thermochemical route, but biological routes mostly susceptible to ambient temperature and anaerobic digester, sunlight for algal ponds, because microbes are susceptible to the change in temperature and pH of the solution. So, mostly complete utilizations of the biomass takes place in case of thermochemical conversion processes, but in biological processes all biomass is not converted completely, it gives some sludge. So, these are the basic difference between thermochemical and biological conversion methods, and obviously the thermochemical conversion methods has more advantages than biological, but there are some specific conditions when biological methods will be more appropriate than the thermochemical conversion methods, particularly when moisture content is very high. Then wastewater as a source of energy, as we have discussed that somewhere the BOD COD value is very high and somewhere the very less. So, somewhere it is say COD is 1 lakhs, somewhere say 1000. So, this in this case we will go for anaerobic digestion, and for this case we may go for microbial fuel cell. So, MFC. So, microbial fuel cell is a very new concept, but this concept is AD is a developed concept. So, these are the different routes on the production of energy from the different types of wastes. At last we will see the some risk of this waste to energy conversion. The first one is all technology options for waste to energy conversions are not matured. The second is residual disposal. Whatever may be the process we use, there will be some residual part. So, we have to dispose it off. So, proper mechanism we have to adopt, how we will manage the residual part, and environmental regulation. Gradually the strict environmental norms are coming up, but as the technologies are not so well developed and mostly many technologies are in lab scale, in pilot scale, etc. So, what will be the requirement, how those environmental requirements will be achieved, that is a challenge. And lastly the economic feasibility, whether these will be this process waste to energy will be economically feasible, because you have seen that the energy content of waste is not very high, but still will it be economically feasible? Maybe or may not be, because this is a new concept, very large applications has not taken place except incineration. So, there is some question mark on this the economic feasibility of the different processes like MFC, whether it will be feasible. But one important characteristics is that if we do not use this waste to energy conversion route, we have to develop some waste management routes, which is costly, it will be having its own cost. So, it is expected that waste to energy conversion process will be having some economic feasibility in future, and the people will be forced to do something to manage the solids. So, after this we have given you some introductions on the subject, and I thank you very much for your patience, and we will start discussions in the next module.